Alright, so this last week we worked on solving systems of linear equations, a system. We used graphing. We also used substitution, which we know substitution is one of the more difficult ones for us. Today, we're going to start talking about the third one. We're going to spend 2 days talking about this third method called elimination method. And the reason we're going to spend 2 days on it is because today we're going to start with the very basic of it. This is the one that I really feel you should have complete control over. This is the one that the majority of the students have looked at and said, oh, this is pretty easy. This makes sense. Why didn't you give us this method to start off with and forget the other two? The purpose is we have to know all three methods. There's times when you will use one of the methods instead of the other, and you have to understand what it represents. But for students, we have found that this third method is their to-go-to method. We'll spend 2 days on it. Today we're going to do the very basic. I'm making it as easy as possible for you to make sure you understand. So, steps to solve. I know you should have this copy, but I'm going to make sure. The first step says make sure the equations are lined up. On today's homework, I've made sure the ones that you are going to do, that is already done for you. You're not having to worry about that second step or that step yet. So, they will be lined up for you. Once they've done that, you're going to do step 2, which is to add or subtract the equations to eliminate the variable with the common coefficient. So the purpose, it sounds like, with the elimination method is we're going to take our two equations and we're going to add or subtract. If you check today, we're only going to be doing the adding, where it gets rid of either the x or the y. So you only have one variable to solve for. Remember, coefficient is the number decimal fraction that comes right before our variable. And that's going to be one of the key things that you have to do today. Step 3, you have to solve for the remaining variable. So if I eliminated x, I'm going to solve for y. After I solve for y, you're going to do kind of what we did last week. You're going to substitute your answer into either original equation, so either equation, and solve for the other variable. Now, here's why this is important that we're writing these down on our notes. You're going to keep them in your 3-ring binder. If you go to start today's homework and you are confused, go back and look at these steps. We're going to do the examples here, but I'm going to add one small change into your work today. Okay, so here's how we're going to do this. Everyone, we're going to do about 4 problems together. Or I'm going to do 2, we are going to do 2, and then you're going to do the rest. Number 1. If you look, I'll erase this part in a second, but they have everything in line. That's what you should always check for. My y's are right above each other. My equal sign is lined up. My x's are lined up. And my constant numbers are lined up. They can be in any order, but I have to have my y above each other, then my equal signs, and my x's, and my constants. They have to be lined up. I cannot write this equation. I do not want to say 2y plus 4x equals 7. The reason this is incorrect is right there. In this one, the equation equals after the y, and this one we're adding. We cannot do that. We need to make sure they're lined up correct. So if we had that, which was on some of the homework, you'd have to solve your equation to get it in the same way. But here's how we're going to work today. If I look at my equation, one of the first things I'm going to do today is I'm going to look at my variables. I have y and I have x. On my first equation, how many y's do we have?
2.
in my first equation?
1.
Just 1. In my second equation, I have
1.
Okay, so right there, my y's have the same number of coefficients. Huge hint, we're going to look at our y's then. If I look at my x's, how many x in the first equation? How many in the first equation?
3.
3. How many in the second one?
1.
Okay, so because the x has different number of coefficients, I do not want to focus on it. I'm going to focus on my y's because they have the same number of coefficients. In this case, it's 1. Here's the extra step, and this is going to make the assignment easier. If my coefficients have the same value of positive or negative, if they're the same, I'm going to take my second equation and times by a -1. Okay, let's listen to that again because we have to make sure that's going to be key. This is a positive y. That is a positive y. Because they have the same positivity, I'm going to go ahead and I'm going to take my second equation and I'm going to multiply the whole thing by -1. And doing that's very, very easy. Because if I times it by 1, it wouldn't change, right? But changing it, or by multiplying by -1, I'm going to change it from positive to negative, negative to positive. Here's why. You're going to see. So I'm going to take my first equation and write it down. So I have a little room to work. So please make sure you're doing this on your paper. I'm going to write out y equals 3x plus 4. On my second equation, because my y on both equations was positive, I multiply the second equation by a -1. So, y times -1 is -y. X times -1 is a -x. -2 times -1 is a +2. The reason we are going to do this today is so on each one of my equations, I can just say I'm going to add. I have now found it is easier just to always add the opposites. We did it in algebra class where we thought about, okay, if they're the same, we're going to subtract. If they're opposites, we add. And we had some big troubles with the subtraction. So we found that if you just do this and you have the opposites, it's easy to add. And we're basing it off of whatever variable we said had the same coefficients. Okay, now let's look at this work. I have a positive y and a negative y. When I'm adding, the trick is now I can just kind of forget that and just pay attention to the signs. If I have 1y minus 1y, 1 minus 1 is 0. So I don't have anything. I had a y and I took a y away. I'm going to write down 0. And I'm really writing down 0 because we have our equal sign still. 3x minus an x. And see, I don't have to pay attention to my thing over here. Because I am saying 3 plus a negative x. But instead of saying that, I pay attention to the sign. 3 minus 1 is
2.
So I'm left with 2x. 4 plus 2.
6. That's your answer.
Almost. Now I have 0 equals 2x plus 6. Do I know what 1x equals?
Yes. 1.
Not yet. It does not say x equals yet. So I have to rewrite my equation. I'm going to do that by subtracting 6. I'm making it so I'm solving for x. So I have negative 6 equals 2x. And I notice I have 2 times x, so I'm going to divide by 2. And I would be left with x equals negative 6 divided by 2 is negative 3. X equals negative 3. Okay? That wasn't too bad. To be honest, that was one of the tougher equations that we're going to do today. Now, I have solved for x, but I still have to solve for y. So now I'm going to kind of put in a little bit of last week's work with substitution. I get to choose either one of my two equations. And to be honest, I think the second one looks a little easier. So I'm going to choose my second equation, which was y equals x minus 2. And I want to solve for y, so I'm going to substitute in x. And for x, well, we just solved it. It's a negative 3. So I would say y equals, instead of x, we say negative 3, and I still minus 2. Well, negative 3 minus 2 is negative 5. Y equals negative 5. My answer in coordinate form is negative 3, negative 5. If I would have graphed this, my two lines would have crossed at negative 3, negative 5. If I would have used substitution, you would have found your answer to be negative 3, negative 5. That does not change. This is just one way to find your answer. Okay? I'm going to do another one kind of by myself, me leading it. And then the next one I'm going to have you guys really help out. So this is kind of like I do, then you do, or we do, and then I do. So, first problem, it says x plus 4y equals 13. X minus y equals 3. Okay, I notice everything's lined up. X's, y's equal constants. Perfect. I'm going to look. This time I'm going to use my x variable. There's one x, there's one x. Same coefficient. So I'm going to use my x as my starting point. I also know that it's both positive x and positive x. Okay, because both of them are positive, I'm going to write down my first one. X plus 4y equals 13. And because the other one is also positive, it had the same positivity to it, I'm going to times it by negative 1. Because I want that x value to be the opposite. So, x times negative 1 is a negative x. Negative y times negative 1 is a positive y. 3 times a negative 1 is a negative 3. And now because my 1x and 1x are opposite, one's positive, one's negative, I can add my two equations. This one becomes very simple. X minus x. Well, I know that's just 0, so they cancel each other out. 4 plus 1. So 4y plus 1y. I have 4 y's. I add another y. I'd have 5y. 13 minus 3. 13 minus 3 is 10. So now I have 5 y's that have a value of 10. All right, let's do that, buddy. 5 y's that equal 10. I want to divide by 5 to find out what just one y is. Y equals 10 divided by 5 is 2. Y equals 2. Huh? No, because the 13 was positive. So I had positive 13 and I took away 3. So you have 13 suckers, I take 3 suckers away, you still have a positive 10. Okay, now that I've solved one, I get to choose either equation. Honestly, the second one looks easier again. X minus y equals 3. And instead of y, x minus, instead of writing down a y, I'm going to put in, well, we said y was a 2. So right now I have x minus 2 equals 3. How do I get x alone right now? Good, Damien. I see that I have x and I'm minusing 2. I want to get rid of that, so I'm going to do the opposite. I'm going to add 2. Add 2. X equals 5. We're all done here.
Really?
5.
X was 5. So my answer's 5, 2. Same thing. If I was to write each equation in slope-intercept form and graph them, the intersecting point would have been 5, 2. If I do substitution, my answer would have came out 5, 2. This is our third method we're using. Okay, I'm going to set this one up, and then I'm going to have you guys work, and I'm going to come around and see if you're doing it right. So I will help you set it up first. 3x minus 10y equals 14, and 3x minus 9y equals 15. X's are lined up, y was lined up, the equal signs lined up, and my constant numbers lined up. Question. Which variable do you think I'm going to be looking at? Am I going to be looking at the x's, or am I going to be looking at the y? And tell me why. Ricky? You're correct, x, but not because it comes first.
Because it's 3x, but the number 3x.
Because my coefficient are the same on both of them. Both x's have a 3 for their coefficient, the number that came right before the variable. If I looked at the y, it was a negative 10 and 9. Those are not the same. I would not eliminate them. So I'm going to look at this. I'm going to take my first equation and write it down. 3x minus 10y equals 14. And now here's the question. I like that you said that, Ricky. He said, am I adding? Well, first, are both of my x's positive or are they opposite? One's positive, one's negative. They're positive. They're the same. So what do I want to do first? I want to, Tyler? Take the second equation and multiply by negative 1. If they have the same value, multiply both of them by negative 1. I'd have negative 3x. Negative 1 times negative 9y is a positive 9y. 15 times negative 1 is negative 15. Now, I want you to go through and solve. I'm going to pause our video here. I want you to solve this equation, and I want you to find out what one of your variables equals. We just did 2 examples like this. You should be able to solve it. I'm seeing a little bit of confusion, so I'm going to step in and work on this. Elimination method, the idea is that we are going to eliminate, when we do the prompt, either x or y. We're going to get rid of it. So, when I do 3x, and I take 3 x's away, okay, then what would I have? If I have 3 x's and I take 3 x's away, I'd have nothing. 0. There is our elimination. I now have negative 10, and I'm going to add 9y to it. So negative 10y plus 9y would leave me with, I still have negative 1, but I'm going to say just negative y. Negative 1y. Make sure you keep that variable with equal sign. 14 minus 15. What? Negative 1. Now, I have negative y equals negative 1. I don't want to know what a negative y is. I want to know what a positive y is. Huh? You divide by what? Negative 1. Good. You can say, guys, it really doesn't matter. You can say I'm going to divide by negative 1. I think that's what Miss Majors loves doing. I always say times by negative 1. But it's not going to make a difference. If I do this, divide by negative 1, negative 1y divided by negative 1, Well, dividing by 1 gives you the same answer, but negative divided by negative is a positive. So negative divided by negative is a positive, so 1 divided by 1 is just 1. We should have had that y equals 1. I now need to solve for x. So I choose either equation, top or bottom, it does not matter. If I look, they look pretty much exactly the same for difficulty. So I'll just go ahead and use the top one. 3x, you would what? Okay. 10y equals 14. And when I, what? You have a question?
No.
Oh. So I'm going to go ahead and rewrite this. 3x minus 10 times 1. Good. Y was a 1. Equals 14. 3x negative 10 times 1 is negative 10. Now I'm going to switch colors since we're doing something. I have 3x minus 10 equals 14. I'm going to add 10 to both sides. 3x equals 24. How do I get my x alone, Tyler? Good. Divide each by the coefficient 3. X equals 8. X equals 8. And that's all we have to do. Okay, there is something that I like on this next equation. We're going to do this one, and then I just want to look. We're not going to work on 2 more. But I'm going to look at something important on 2 equations, and then I'm going to give you guys some more time. So, on number 4, let's do this one kind of together again. There's something important about it. They're lined up. Don't shout out stuff. You don't want everyone to be able to think. They're lined up. X above x, y above y, equal above equal, and the constant above the constant. When I look at this one, which variable am I going to focus on? Am I going to focus on the x's or the y, and which one, and y? That made me think of when I said which one, x or y and y. Like what? Which you really? Hold on, let a couple people think, Cohen, then I'll call on you.
You call me that.
Everyone try and look up, see if Cohen's going to get this right. Right, make sure you're following. I want you to be able to do this tonight. All right, Cohen, which one are we going to focus on? Are we going to look at the x or the y, Cohen?
You're going to focus on y because both of them are not. X is not. Both of them are not positive.
Why?
They're not the same. Yeah, they're not the same. They're not the same number, and they're also different. Like one's negative, one's positive.
Okay, I like that you said that because I want to clarify something. If I'm hearing right, Cohen, you're saying we want to look at the y because the x is a positive and the x is a negative. Okay, that we don't want to confuse that. That doesn't matter to me right now. That's going to be in our next step. I don't care if both are positive or negative yet. I do want to look at y. What is special about the y's?
They're the same.
What's the same?
They're both positive.
Nope. I don't care about that yet. The coefficient. Remember, the first thing we got to do is look for the coefficients. So, I'm going to scroll real quick and look. On this one, number 5, which variable has the same coefficient number?
X.
X. So I am going to focus on x. 4x, negative 4x. On number 6, which one has the same coefficient? Y. Negative 3, positive 3.
Each equation always have one that's right.
For today's work, you will. For tomorrow's, you have to do a step to help with that. On number 7, which variable has the same coefficient? Bryce?
Y.
Yeah. Negative 1y, positive 1y. On number 8, y. 3y, negative 3y. Okay, we're going to come back down to these in just a second. So, we were right. We want to look at y. It's 2y and 2y. But now we have to look. Look at the value. Are they both positive, or is one positive, one's negative?
Both positive.
Both are positive, because they're both adding 2. Because of that, I will multiply by my second equation by negative 1. I want them to be opposites. So, I will have 4x plus 2y equals 6. That's my first equation. My second equation, after I times by negative 1, what will be my equation? After I times by negative 1.
Positive 2x. Negative 2y.
Perfect, Ricky. Negative 2x becomes 2x. Positive 2y becomes negative 2y. Positive 18 becomes negative 18. We solve now. 4x plus 2x equals 6x. 2y minus 2y.
0.
0. I have 2 y's. I take 2 y's away. That is the one that's eliminated. Huge hint. Today, if you don't eliminate one of the variables, you did something wrong. So 2y minus 2y is nothing. Equals 6 minus 18. I messed this up last hour. One of the students asked me checkers. I looked at it, I was like, yep. And then I went up here and I was like, nope. 6 minus 18 is negative 12. For some reason, when I did it, I thought negative 24. So make sure you take your time with integers.
They make each other.
Now, how do I get x alone? Ooh, I got a lot of people saying it. Right? X equals negative 2. Not sure why it went dotted on me, but okay? It's okay. Oh, focus. Let's just have some of the comments. I want to finish this. I then put this into an equation. I'm going to use the first one because it's positives. So 4x plus 2y equals 6. I will rewrite it as 4 times negative 2 plus 2y equals 6. I had substituted my negative 2 in for my x. 4 times negative 2 is negative 8 plus 2y equals 6. Very good, I heard that. Whoever said that. Add 8. 2y equals 14. We finish by dividing by 2. Thank you. Y equals 7.
This homework can be a breeze and I'm popping.
You want to simplify it?
Okay. This is what you were doing for me today. 2 problems I'm going to look at, and I'm not going to work them. I just want you to visually see something before you get started. On number 5, you guys already highlighted, you said we're going to focus on the x because it's 4x and a negative 4x. What is different between that and all the other ones we've done? Rylan? Good. Their values are already opposites. So, I would, if I was you, underline or circle whichever variable that you are going to be looking at that has the same coefficient. And on this one, because they are opposite values, positive 4x, negative 4x, I do not have to do the times by -1. If it's opposites, you just go ahead and say, I'm now going to add my two equations. Because your 4x and negative 4x would cancel out. And I'd have 16y equals 16, y equals 1. And you still substitute and solve x. The other one I want to look at before I start you. What do you notice about number 8?
They don't line up.
What, Dawn?
They don't line up.
Okay. They do not line up.
I know what.
What happens if they do not line up?
They're not tight with each other.
Hold on, I gotta hear it. Braden's saying something.
Never mind, I'm probably wrong.
Tucker, what do you think? Okay, how do I move them to line up?
Andy, shut up. I don't know.
What do you think we do?
I'll free.
Okay. Tyler?
You get around by.
Listen up.
On this one, you add 3y to the other side.
Okay, good. So I have to solve. Since this one's solved for x, I just have to do the same thing. So it's x equals 3y plus 11. I would take this second equation, that is 2x minus 3y equals 16, and I would add 3y. Now I have 2x equals 3y plus 16. And I can copy this one. Focusing. Let's not get off task. And I can still have this. And then we can solve it. Alright. Focus, so I can tell you your homework for tonight. Your homework
How hard?
for tomorrow. Same thing. You are only going to do 1 through 8. 8 problems for tomorrow, that's a completion grade. It's only the front side. I took the back side off because on those you would have had to rearrange your equations. So, 1 through 8, it is a completion grade.
Tell coach.
Any questions?
You're right.
Your homework and your quiz gets turned into the train.